Okay, lesson 3.4, example 6. We're just solving log equations. And if you read through the previous couple slides there, it talks about another little way to do it somewhat. But we can use that. Remember, we know the fact that log base a of x equals y, and we can change that to exponential, saying a to the y equals x. We can use that same method here. So remember, the natural log has a base of e. It's not written, but we can put it there if we need to see it. And so we can say, okay, well, let's set it up in exponential. So a to the y equals x. And this one didn't say it around or anything, so we can leave that then as x is equal to our e squared. On b, it's a little different. We've got a log of base 3 of something equals a log base 3 of something. Well, when you have a log equals a log, you can go ahead and just cancel those logs, remember, using that one-to-one property. So we know that 5x minus 1 is equal to x plus 7. Let's just solve for x. So I'm going to subtract this x over here. I'm going to add the 1 over here. We end up with 4x equals 8. Divide by 4. And we end up with x equals 2. Now the only thing, and I did mention it on A, but is you got to make sure that when you plug that x value that you just solved for in to whatever you're taking the log of, it has to check. It has to be positive. Remember, because we can't take log of 0 or a negative number. So I need to come over here. I'm going to do a little think bubble for B. A was just x equals e squared. It was fine. E squared is positive. So, but when I plug in that 2, I'm not real sure. So I've got to look at first the first one, which was log base 3 of 5x minus 1. But now it's not 5x, it's 5 times 2 minus 1. Well, 5 times 2 is 10, minus 1 is 9. So I'm really taking log base 3 of 9, which I can do. Then check the other one. We've got, was it log base 3 of x plus 7, but it's not x, it's 2 plus 7, which is log base 3 of 2 plus 7 is 9. Again, they should be the same because there was an equal sign between them, but the main thing we're looking at is, yes, we can take the log of 9, and therefore they're both okay. Then on C, what are we going to do on C? Well, C, I have log base 6 minus log base 6 equals log base 6. Can't cancel your logs because these two are not just one log. But can I make them one log? Yes, because they're log bases that are the same with a minus sign, we can combine them. And do you remember how to combine when they're being subtracted? You can combine them by dividing. So you get log base 6 of the first over the second. And we're going to set that equal to that log base 6 of 2x. Well, now I do have a log base 6 equals a log base 6. So now I can cancel those log bases, and we get 3x plus 14 over 5 equals 2x. Well, let's start solving. First, let's get rid of the fraction. So we're going to have to multiply by the 5 that's on bottom to make it cancel. Excuse me. So what I get there then is 3x plus 14 equals 2x times 5 is 10x. And let's just solve for x. So subtract your 3x. So 14 equals 7x, divide by 7, and we find x is 2. But remember again, we have to check it. So let's see, when I go to plug this one in, I'm just going to do it right above it. So 3 times, we said x was 2, plus 14, 3 times 2 is 6, plus 14 is 20. That's positive, it's good. The second log we have there is just a 5. We don't plug it in, so it's fine. And the third log that we're looking at is 2x, so that's 2 times, we said x was 2, 2 times 2 is 4. We can take log of 4, therefore x equals 2 is our solution. And I should have boxed that one as well when I found that it worked.